Okay, and welcome to geometry definitions. The first one, adjacent angles. Two angles that are next to each other and share a common vertex and a common side. So this is what the picture would look like. It needs to look like this. These two angles would be next to each other and they share a common vertex, which we'll call this B. We'll make this A, B, C, and D. And they share a common vertex and a common side. So the side would be ray BD. The next one, vertical angles. Angles that are across from each other. Vertical angles are congruent. So remember, if this was 70 degrees, this would also be 70 degrees. Another pair here that are vertical angles, these two would be 110 degrees each. The next one, a median. A median is drawn from any vertex of a triangle and cuts the base into two congruent parts. So we're going to take a median from here and it would go, let's say, to here, and that means that those two pieces are congruent. So a median cuts the base of a triangle into two congruent parts. Slightly different than an altitude. In an altitude, it would be perpendicular to the base. So in this case, the altitude would drop down here, and we would make two right angles in that case. So drawn from a vertex and then is perpendicular to the base. Notice that in this case, here, these two pieces on the bottom are not necessarily equal. They are perpendicular, but they're not equal. And in the case of the median right above it, this is not a right angle right there. However, the two pieces are congruent. Okay, the next one, a linear pair. Two adjacent angles that form a line and are supplementary. So if I told you that this was 60 degrees, we would automatically know that this was 120 degrees. The next one, perpendicular lines. Lines that intersect and form congruent right angles. Technically, there are 4 right angles right here. Typically, we only label one of them, so by putting a little square in the corner there. The next one, a midpoint. A midpoint cuts a segment into two congruent parts. So the most common midpoint would be M, and it might say that M is the midpoint, so we know that AM is congruent to MB. Okay, and then I know that I'm going pretty fast, but if you need to, pause the video to copy down any of the definitions. Let's go to the next page. All right, so the next one, a perpendicular bisector, a segment that is both perpendicular to and cuts another segment in half. So right here, the perpendicular bisector would make right angles and would cut this segment into two congruent parts. The next one, an angle bisector, a segment or array that cuts an angle into two congruent parts. So let's say I had a ray in here and it was the angle bisector. That means that this angle is congruent to that angle. Now, in addition to angle bisectors, we could have segment bisectors. So in this case, I might draw a line that looks like this, and a segment bisector would tell me that this piece is congruent to that piece. So that's a segment bisector. The next one, an isosceles triangle. Please make sure it looks isosceles-like. So it's going to have two congruent sides and two congruent base angles. So two congruent sides and two congruent base angles. The next one is an equilateral triangle. The interesting thing about this is that all three angles measure 60 degrees each, and all of the sides are congruent, so we're going to label that with a single tick mark. The last two definitions, complementary angles, two angles that add up to 90 degrees. So this one might be 45, and that one might be 45, or they could potentially be 46 and 44. Either way, they have to add up to 90 degrees. And then in the last scenario, supplementary angles, two angles whose sum is 180 degrees. So I might tell you that this is 52 degrees, and that this other one would be 128 degrees. And those add up to 180. Thanks, and I'll see you tomorrow.